Hi everyone, welcome back to my channel. And today we are discussing the solutions of our test paper second. It consists of three questions, so let's get started. Question number one states what are the stages of text mining, and here we have considering and complaint that is theft of my mobile phone by an unknown person at MG Road on 20330220. The phone was stolen when I was shopping at a store. The thief was wearing a black jacket and had a scar on his face. Now, here we are using text mining process. So the first step in text mining is text pre-processing, where we clean and transform the raw text into a format suitable for analysis. So let's break down it. So firstly, we remove unnecessary characters, that includes punctuations or any special characters. Then lowercase the conversion, that is maintain uniformity to convert all the text into lower case. And then we have tokenization, that is breaking the text into words or phrases. Next on, we have stop word removal, like words like and or the is are commonly removed because they don't add meaning to our analysis. So here this was our sentence, so we just filter out only the important words from the text. Next stage is name entity recognition, that is NER. So we use it to identify and extract important identities from the complaint text, such as crime type is theft, location is MG Road, now date is there, and the appearance of the thief, and scar on his face, that is physical features. And here now the next stage is feature extraction, that is we convert text into features that can be processed by algorithms. There are many popular techniques such as bag of words, where a representation it is a representation where each word is treated as a feature. Next on, we have term frequency inverse document frequency, that is TF-IDF. That is a more advanced technique that weights the word based on their importance in the document. Next stage consists of text classification, where we assign a complaint to a relevant IPC or BNS category. For example, here section 378 IPC is for theft based on keywords like theft and mobile phone. Now, this can be achieved using machine learning algorithms such as a knife based theorem, support vector machines, or even random forest for classification. Next stage we talk about is information retrieval. So, once we classify the complaint, the next task is to retrieve relevant sections from IPC BNS database. We can use techniques like similarity matching to find the most relevant sections based on the complaints feature. Consider an example where in this following example, where there is IPC 378, section 378, that is for theft, and punishment for theft is IPC section 379. Now next stage is recommendation. So after the classification and retrieval is completed, the final task is to recommend the relevant IPC-BNS section to the user. For instance, in this notebook, we have given crime type theft IPC sections such as IPC 378 for theft and BNS section 79 for person causing suspicion. Now, approach recap. So let's summarize what we have done for our approach. That is firstly text pre-processing, then classification algorithms such as naive bayes theorem or support vector machines. Then we have NER that use tools like Spacey or NLTK to extract entities like crime type and location. And we have rule based matching or similarity check. And then we have recommendation system that based on the extracted details, we will recommend the crime type and theft and the specified IPC section for it. Now, moving on, we have this example. We have this example and we have solved it. You can just go through it once. Let's move to our second question that talks about the algorithm for give algorithm for code snippet for the suitable following task. So firstly, we have data pre-processing, classification, clustering, decision tree, and association rule mining. So let's get started. First part about data pre-processing. So it is very important step for data to get into analysis phase, and this step typically includes like removing noise such as the values which do not mean any useful to the data, and handling missing values such as there are many missing values such as there is age group is there and there is no value included, and encoding the data into a suitable format. So here is an example where cleaning the text data is there and handling the missing values for normalization. So in this code, we have imported pandas, that is pandas as PD, and then we have import re. One second. Import re. So what is it? It's a library in Python that is used for text pre-processing, uh, and this is stands for regular expression, which allows you to work with text-based platform, enabling the patterns like matching, searching, or replacing text. And then SQL pre-processing. Now here we have an example data set where the text is there, and then TF, it is the data frame we are converting to data frame, and then handling the missing values and cleaning the text data, and then standardizing the numerical value. Let's just run. It might take a bit long time. So read the following output that gives us the text and amount and text cleaned from the original raw text which was given to us, and then the standardized amount, that is we fit and then transform our database for the amount, and the behavior will change in pandas, and the in place method will never work because the intermediate object will which are suitable for setting the values will behave as a copy. So this is the output for text pre-processing. Now let's move to classification. So classification is involves assigning labels to the given set of input data. Common algorithms such as logistic regression, naive Bayes, and support vector machine does the classification for a data, and it what does it do? So it process it is the process that predicting the category of the class label of an given input based on its features. It is a supervised learning task where the algorithm is trained on the based on a label data set to learn patterns, then predicts the labels for unseen data. So what its process is? It's firstly splits the data into training and testing sets. Then it trains a classification algorithm based on labeling data, and then it uses a model to predict the labels for unseen data. Now we have given here code, so we are firstly doing the text classification process where the text is there and label is there. Consider it at x and y. Consider it, and then we are vectorizing x data, that is text, and then we are splitting the data into training set and testing set, and then we are classifying using naive Bayes classifier, that is training the model using naive Bayes classifier, and then predicting and evaluating. Let's try to run this too. Yeah. So it has our model has been trained and the accuracy is zero point 0. Moving on, we have our C part, that is clustering. So clustering is is a unsupervised learning task where the goal is to minimize intra-cluster variance, that is point within the same cluster are as similar as possible, and maximize inter cluster variance, that is cluster are direct distinct as possible. Unlike classification, clustering does not require label data. It's typically used for data exploration, customer segmentation, and anomaly segmentation. And it has different algorithms such as k-mean clustering, hierarchical clustering, db scan, and many more. What is its process? Firstly, it extracts the features from data, apply clustering algorithm, visualize or interpret the clusters. Now, in this code, we have imported sklearn, and then from that cluster, and then we are clustering our numerical data, which is a simple basic data, and then applying k-mean clustering, which we are importing the k-means and creating two clusters. Okay. Since the data is really less, so our clusters aren't formed that in that particular way, and we have plotted a plot for it. Next on, we have decision tree. So, a decision tree is a supervised learning algorithm that is used for classification or regression tasks. It splits data based on feature conditions, such as training the model. Yeah. So, such as train the decision tree model using labeled data, visualize the tree structure, and make prediction. Now, let's see the code. So here we have imported, let's try to run it first as it might take a bit time. Now sklearn tree, import decision tree classifier, and then plotting the plot tree that will give the visualization of our tree. Now iris is a sample data set, as I mentioned earlier in my previous videos, and then we have training the data set and then visualizing the tree. So here we have a sample data, that is this, and then we are predicting it. So here you can, as you can see, it has petal length, Gini, sample values. The Gini is another technique, and we have values. Now if it will be true, the values of Gini samples would be 50 and this, and if it is false, the samples will be 100. Now if the petal length is less than 4.95, the samples will be 54, and if the petal is the class is versicolor, it will be this, and if the class is virginica, it will go to this. And the predicted class after this tree is setosa. And last point, we have association rule mining. So it is again a technique in machine learning, in data mining especially, that is used to discover interesting relationships between the variables in large data sets. It is often used in market-based analysis and to find associations between the product purchased together. For example, if customers who buy milk are also likely to buy bread, an association rule can be applied. Now, in this code, we have imported MLXtend library, and then we are running it. And we also have a sample data set for milk, bread, butter, jam, and creating a database and then running it to this. So here the error is coming for because we do not have num item set. So this might create a also you must face the problem because this is a not updated version of it. So we'll just give a dummy value that num set is equals to num set with a comma in between. Let's try to run this again. Okay, I okay, so there is some error, I need to solve it. Just hold on a second. Okay, let's try running it again. So here I have written num item set is equals to num item set, and then I have got the output that is for frequent item set and association rules, and and these are the tables from the association rule mining. Now, third question is, give algorithm and Python code snippet for linear linear classification model for the least square principle and for fitting the best curve in scatter plot. So linear model is uses the least square principle for a best fit linear curve in scatter plot. The least square method minimizes the sum of square differences between the observed points and the predicted data points in the line. Now explanation of the algorithm. So suppose x is the array of input features and y is the array of output features. Now calculating the mean for x and y will be is equals to summation of xi minus x mean multiplied by yi minus y mean by divided by the summation of xi minus y mean whole square, and then calculate its intercept, that is y mean minus x of x multiplied by uh, slope, and then generate predictions, that is for every prediction for every x there is a predicted value y pred, that is m slope multiplied by x plus p, and then plotting the results. So in this code I have imported numpy and matplotlib and then generating a synthetic scatter plot data, and giving a random seed, that is random data, and random data points for x are this, and then linear relationship with noise is y, and then calculating the parameters for the best fit line using least square principles, and defining it, and then calculating the slope and y-intercept according to the formula we discussed earlier, and then computing the slope of y-intercept, and then predicting the values, and then visualizing it by using a scatter plot, and here a scatter plot with the line plot. So here as you can see the best fit line is there and the scattered are data points are there, as we consider the data is random. Now output is the scatter plot, and the best red line, that is best fit line, passes through the minimizing square differences between the observed values of y and predicted values of y print. So that's it for this video. Make sure to like. Thanks for watching.